Okay, this is an excellent problem. A taxi company charges passengers $1 for a ride. That means just to start the meter, just to hop into the cab, you're going to be paying $1. And then for every mile that you travel, you're paying another 30 cents. So the function rule given, it shows you here, is that the cost is going to be 30 cents per mile plus that extra dollar. Okay, so describe the relationship between the number of miles M and the total cost of the ride C. It also says that the taxi can only go a maximum of 40 miles, so it's a reasonable graph. So here's the idea. Can you go 0 miles? Yeah, I could jump in and say, okay, hey, and the taxi guy puts the meter down, and then I say, oh, just kidding, I got to actually do something. I forgot to do something, and they say, well, you made me turn down the meter, so I have to charge you $1. Okay, so what does that mean? That means that at 0 miles, you should be paying $1. That's that point right there, right at the intersection where this is the number of miles you've gone and this is the cost, because of course you can see that the cost is dependent on the number of miles. So this is the number of miles. I've gone 0 miles, cost me $1 just because I had the driver start the meter for me. Okay, so that's accurate for that. That's accurate for that as well. Okay, here this suggests that somehow you're not getting started until mile 10, which logically doesn't really make any sense because you can go any amount of miles, less than 10 certainly, so that should be graphed as well. So I'm going to eliminate B just on principle by saying we can do, I'm sorry, B and D. We could go any amount between 0 and 10 miles. We should have something graphed there. Now, as you increase, as the number of miles goes on, you see us going along this x-axis, the number of miles, the number of miles, the number of miles. Well, as it pointed out, you can only go a maximum of 40. It needs to stop there. You can't keep calculating for what the cost will be beyond 40 miles because the driver can't go past that. There's a 40-mile maximum, and in real life terms, just to chat about why might that be? It might just be that having the driver drive 40 miles away really takes them pretty far away from where they are, and then they have to drive all the way back into town without any fare. Versus if they stick around in town, they can drop somebody off immediately, pick somebody up. It's very unlikely that 40 miles away from the city, they're going to pick somebody up that happens to be wanting to go into the city conveniently right when they need them to be wanting to. So not getting too far away from the city is the idea of that limit. So it doesn't make sense to go past 40. And that's why we have as our domain, let's just talk about this in terms of domain and range. As our domain, you can go any number of miles between 0 and 40. So those are the only input values that make sense. And if I wanted to write that down, I would say M, let me write in blue, M has to be greater than or equal to 0 because you can't go less than 0 miles in the taxi. Although you can go 0 miles. Like I said, you can jump in, they put the meter down, you immediately say, oops, I made a mistake, and then they say, well, okay, we got to charge you for 0 miles plus $1. But the maximum that you could go is 40, so it's got to be less than or equal to 40. So this is a domain for the situation. And then just writing it down here, what would the range be? C, well, C, it's always going to be greater than or equal to $1. We have to pay $1 if we start the meter. Okay. Now, if we went 40 miles, 40 times 0.3, 40 times 0.3, or 0.30, 0.3, 0.30 is the same, would be $12, would be the maximum for that. So then you could say, okay, $12 is the maximum I could pay if I went the full 40 miles plus $1. So I would have a $13 maximum that you'd end up paying in a taxi in this situation. That'd be the most that you would pay if you went the full 40 miles at 30 cents a mile. So between 0 and 40 for M is the domain, and that's the range. And yeah, so it didn't ask that, but I just wanted to kind of show that to you because in a sense it did. In a sense it did ask you to understand that, because watch what happens here. Okay, if I draw a perfectly vertical line here at the highest input value, you can see that that's highest input value is 40, and then here that highest that highest output value, the highest cost would be 13. It's really got to stop there. So in that situation, this part of the graph eliminates that as a possibility because you're never going to go past 40 and you're never going to end up paying more than $13 in this situation. So we are going to eliminate C and choose A as our option, as our answer.